Here we're going to be investigating the transformation f of x plus a. And we're going to use this table of values to do this. Our function of x here is x squared. The function of x plus 2 is x squared plus 2. So we're looking at a transformation of this type with a equal to 2. We're going to complete the table of values. Minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, then we get 0, 1, 4 and 9. Computing for x squared plus 2 gives 11, 6, 3, 2, 3, 6 and 11. And if we compare the two rows, we can see that the bottom row is just 2 more than the top row at each stage. We're going to draw the graph y equals x squared and the curve y equals x squared plus 2, using the bottom row here for x squared plus 2 and the top row for x squared. And we can see the curves drawn below. If we look at the blue curve, at every x coordinate it is the red curve shifted up by 2 units. The red curve is y equals x squared and the blue one y equals x squared plus 2. We commented from the table that x squared plus 2 was just 2 higher at each point than x squared, and we can see this effect now on the graph. So the transformation x squared plus 2 moves the curve upwards by 2 units. This works with other curves as well. Here we're comparing x cubed and x cubed minus 3, so our f of x is x cubed, and we're also considering f of x minus 3, the x cubed minus 3. We have the graphs drawn as well, and the red one is y is x cubed. The blue one, therefore, is y is x cubed minus 3. If we consider the table, we can see that the coordinate is moved down by 3 units. And we can see the same if we look at the curve. So the effect of the minus 3 is to move the curve downwards by 3 units. Generally then, for this transformation, f of x plus a, we get f of x shifted by a units upwards. So if a is a positive number, as we saw with a equal to 2, the graph moves upwards by 2 units, and if it is a negative number, as we saw with a equal to minus 3, the graph will shift downwards.